Okay, let's try the quadratic sequence here. Look, it goes from 7 to 11 to 17. And if you know how to work these sequences, you know to make a triangle like this. And you just subtract. You go 11 minus 7 is 4. 17 minus 11 is 6. Those are called the first differences. So it goes from 4 to 6. The next number is going to be 8. You subtract these two numbers, the differences, the first differences, you get the second difference. 6 minus 4 is 2. 8 minus 6 is 2. See, it's going up by 2. When the common difference, second difference is, the common difference is 2. When it goes constant, you know you have a quadratic sequence. Well, we know it's going up by 8, the next one. So 17 plus 8 makes the next term 25. And then if we add 10, because it's got to go up by 2 more, the next one's 35. Now, how do we know it's quadratic? I just said it, because the common difference, the second common difference is constant at the end. The second common difference. Okay. Show that the general term is n squared plus n plus 5. You have to know how to do this thing where you put 2a equals 2, and then you get a is 1. That's 3 times 1. b must be 1 to make that equal to 4. You put 3a plus b, and you make it equal to the first difference. And then a plus b plus c equals 7, the very first term. Well, a is 1, and b is 1, so c's got to be 5. Well, 1n squared plus 1n plus 5. Here, we just showed that the nth term is exactly like they said, n squared plus n plus 5. Which term has a value of 557? Well, you take that 557 and you make it equal the formula for the sequence. Then you subtract 552. And now you might want to put that into the quadratic formula. A is 1, B is 1, and C is this big giant negative number. When you press equals when you put it into the quadratic formula, you'll get two answers. The positive answer is your answer. It's the 23rd term. The last question, between which two terms will the first difference be 84? Well, here are the first differences. So we want to figure out, so that's t times 2n plus 1. Does that make sense? It's going up by 2, so it's 2n. If there was a number up to the left, it'd be 2. That's why we add 2. 2 times 1 gives me 4. 2 times 1 is 2, plus 2 is 4. 2 times 2 plus 2, I get 6. Hey, that works. I want to find out what term works for 84. So I put 84 as the first difference. I subtract 2, divide by 2. It's the 41st term. So it's between the 41st and the 42nd. I didn't type that in properly. It should be between the 41st and the 42nd term. That's where the difference will be 84. You can think through this yourself, but that's how it works.